imagine you're standing at the edge of an ocean at night. You can't see the far shore. You've never seen it. Nobody you've ever met has seen it. And you throw a stone as hard as you can into the dark, and you hear it land somewhere out there, and then you wait. That's roughly what we did. We sent a signal into the void, and here's the part I still can't quite get my head around. Something in the dark seemed to answer. Now, sit with that for a second before we go any further, because I want you to notice what your mind just did. Some part of you leaned in. Some part of you got a little nervous. Some part of you already decided it was aliens, and another part of you already decided it was nonsense. And both of those parts of you jumped to a conclusion before either of them had a single fact to stand on. That's the whole game right there. That gap, the gap between what we believe and what is actually true. That gap is where we're going to live for the next little while, you and me. Because here's the thing, almost nobody tells you. The universe is knowable. It really is. But it is not yet known. And that space in between, that enormous echoing space between what could be understood and what has actually been figured out, that's not a problem to be embarrassed about. That's the most exciting real estate in existence. And I get to walk you through a corner of it. I honestly can't believe you're here for this. Think about how strange the situation really is. We are creatures who evolved on the surface of one small rock to worry about food and weather and each other, and somehow that same brain now sits and reasons about the oldest light in existence. That should not work. There's no obvious reason a mind built to dodge predators should be able to figure out the age of a galaxy, and yet it can. That's the miracle hiding inside all of this. Not the aliens. The fact that you, sitting where you are, can follow the argument at all. And I don't mean follow it on faith. I mean follow it the way you'd follow a set of directions, one turn at a time, checking each one against the road in front of you. That's the promise I'm making. Nothing in this is going to ask you to believe. It's only going to ask you to reason. So let's begin properly, not with the answer, with the tools. Before anyone gets to tell you what a signal from deep space means, you and I have to agree on something more basic. How do we know anything about the sky at all? Because if we don't nail that down first, then every wild claim gets to walk right in the front door wearing a nice suit, and you won't be able to tell the honest ones from the con men. So let's build the floor before we build the house. Start with the simplest fact there is. Light takes time to travel. It's fast, absurdly fast, about 300,000 kilometers every single second. But it is not infinitely fast. And that one limitation changes everything about how you see the universe. When you look at the sun, you're not seeing the sun as it is, you're seeing it as it was 8 minutes ago. If the sun blinked out right now, you'd have a full 8 minutes of ordinary sunshine before you had any idea. You'd be sitting in light from a star that no longer exists. Let me make that number honest, because I don't want you to just take it. The sun sits about 150 million kilometers away. Light covers 300,000 kilometers a second. Divide one by the other, and you get around 500 seconds. That's a little over 8 minutes. I didn't pull that from a hat. It fell straight out of two numbers you can hold in your hand. That's how this whole thing is going to work. Every time I hand you a number, I want to show you the little sum it came from first, so you never have to trust me. You only have to trust the arithmetic. Now, let me push that same idea a little further, because it gets better. Light takes about 1.25 seconds to reach us from the moon. So when you look up at the moon, you're seeing it a heartbeat ago. Look at Jupiter when it's near, and you're seeing it more than half an hour ago. The whole solar system is a set of clocks, each one showing you a slightly different past, and the further out you look, the further behind the true time you fall. There is no single instant you're ever looking at. Your view of the sky is always a smear of different moments stitched together into one picture. Hold that, because it's about to get much stranger. Now stretch that out. The nearest star beyond our own is a little over 4 light years away. A light year is just the distance light covers in a year, and it is a staggering distance, roughly 9.5 trillion kilometers. So when you look at that nearest neighbor star, you're seeing 4 years into the past. Look further, and you see deeper into history. The light from some galaxies left them before there was an Earth, before there was a Sunday. This is not a metaphor. This is plumbing. The night sky is a machine that shows you the past, and the further out you look, the older the news. And here's a way to feel that distance in your bones rather than just reading it. Imagine you could travel at the speed of light. Nothing can, but imagine it. You'd cross to that nearest star in 4 years. Now imagine you're in the fastest machine humans have ever built, one of those probes that went screaming out past the planets. At that speed, that same trip would take you not 4 years, but something like 70,000 years. 70,000. Longer than our whole recorded history, several times over, just to reach the closest star. That's the real texture of the gap between us and everything else. Hold that number, we're going to need it. And let me put one more picture beside that, because 70,000 years is itself too big to feel. 70,000 years ago, there were no cities, no writing, no farms. Human beings were small bands of hunters scattered across a cold world. If one of those bands had launched our fastest probe on the day they lit their first fire, aimed perfectly at the nearest star, it would only be arriving about now. That's one star. The near one, the friendly one next door, every other star is further. Some are thousands of times further. This is the size of the thing we're standing at the edge of, throwing our stone. So here's the first uncomfortable truth. We can never see the universe as it is right now. There is no now that stretches across the cosmos. Every point of light you see is a different age. You're looking at a photograph album where every photo was taken at a different time, all pinned to the same black wall. That's not a flaw in our telescopes. That's the structure of space-time itself, that woven fabric of space and time that everything moves through. And this gives us our very first honest rule. Distance and time are the same currency. To look far is to look back. You cannot separate the two. Hold on to that, because it's going to matter enormously when we talk about signals. Now, the second tool, how do we ever decide that an idea is any good? And here's where I want you to be a little ruthless with me. Don't trust an idea because it sounds beautiful. Don't trust it because a confident voice said it. Trust it only if it could be proven wrong and hasn't been. That's the word that does all the heavy lifting in this whole subject. Falsifiable. An idea is worth something only if there's some observation, some possible measurement that would kill it, stone dead. If nothing could ever disprove it, then it isn't telling you anything about the real world. It's just a story that feels nice. Let me show you the difference with two claims side by side. Suppose I say there's an invisible dragon in my garage, but it's a dragon that gives off no heat, makes no sound, and can't be touched or photographed. What test could you run to catch it out? None. Every test comes back blank, and I just say, well, that's exactly what an undetectable dragon would look like. That claim is worthless, not because it's necessarily false, but because there's no way for reality to argue back. Now, suppose instead I say a planet orbits a certain distant star, and it should pass in front of that star every 11 days and dim it by a hair. That claim is naked. You watch. If the star doesn't dim on schedule, I'm wrong. And everyone can see I'm wrong. That's a claim worth having. It sticks its neck out. Feel the difference? The good ideas are the brave ones, the ones that could get caught. And notice, that second claim is exactly how we've found thousands of real worlds around other stars. We watch a star patiently for weeks. If a planet crosses in front of it, the star's light dips by a tiny, precise amount on a schedule, again and again. That dip is the shadow of a world we cannot see directly. It's a claim that could have failed at any moment and didn't, night after night, for thousands of stars. That's what a good idea looks like when it survives. It doesn't just sound right, it keeps passing the test that could have killed it. Let me show you why that matters with the signal. Suppose I tell you the universe is full of civilizations chattering away, and we just caught one. Lovely idea. But what would have to be true for that to be false? A lot, actually. And a good thinker asks that question first, before falling in love. What's the plainest explanation that fits the same facts? That's another tool, one you already own. It's usually called Occam's razor, and it's dead simple. When two explanations fit the same evidence, prefer the one that asks you to believe less. Not because the simple one is always right, but because you should make the universe prove it needs the complicated one. Occam's razor gets misunderstood, so let me be careful with it. It does not say the simple answer is always correct. Sometimes the truth is genuinely strange and complicated, and the plain story turns out to be wrong. The razor isn't a law of nature. It's a rule about where to place your bets before the evidence is in. If someone shows you a knocked over lamp, you should reach first for the cat did it, before you reach for a burglar broke in, knocked over exactly one lamp, and stole nothing. Both fit the lamp. One asks you to believe far less. You start there, and you let the extra evidence, the open window, the missing jewelry, drag you toward the bigger story only if it has to. That's all the razor is. A sensible starting place, not a verdict. So already, before we've looked at a single strange signal, you and I have a toolkit. Light carries the past. Distance is time. An idea is only as good as the test that could break it. And when in doubt, reach for the simpler story until the facts force your hand. Notice something wonderful about that toolkit. None of it required you to trust me. Every piece of it you can check with your own reasoning from your own armchair. That's the whole point. That's what scientific literacy actually is, by the way. Not a head full of facts, a handful of tools for telling a good claim from a bad one. And you've just built 4 of them. And there's one more idea I have to hand you before we go on, because everything downstream leans on it. It's the assumption that we are not special, that our position in the universe is ordinary, average, nothing chosen about it. Some people call this the Copernican principle, after the fellow who worked out we're not at the center of things. The mediocrity assumption, it's sometimes called, which is a wonderfully humbling name, and it cuts both ways, which is the delicious part. If we're ordinary, then whatever happened here, life, curiosity, radio antennas, probably happened elsewhere too. But if we're ordinary, then we're also not the audience the universe was waiting for. Nobody's been holding the line for our call. And notice how much work that principle has already done in history, quietly, every time we assumed we were at the center and turned out to be wrong. We thought the Earth sat still and everything circled us. Wrong. We thought our sun sat at the heart of the galaxy. Wrong, it's out in the suburbs. We thought our galaxy was the whole universe. Wrong, it's one of hundreds of billions. We even thought our kind of star and our kind of chemistry might be rare. Wrong again. The same elements that make us are scattered through every corner of the sky, glowing in the light of distant stars. Every single time we bet on being special, we lost. So the mediocrity assumption isn't just a nice piece of humility. It's the smart money. It's the horse that keeps winning. And that's exactly why it's so unsettling when we point it at the question of life and the answer comes back strange. So now, with that floor built, we can walk out into the strange. And the first strange thing is a rock. Just a rock. But wait until you hear what the rock did. Here is a claim I want to lay down flat on the table. In 2017, an object came into our solar system from another star, passed close to our sun, and then behaved in a way a plain rock is not supposed to behave. That's it. That's the whole strange thing. And it's stranger than it sounds. Let me build up to why. We watch the sky. We track things that move. Most of what moves near us is local, born in our own solar system. Comets and asteroids on long, slow loops around the Sunday. Think of the Kuiper Belt. That vast ring of icy leftovers out past the last planet, quietly circling where the sun is, just a bright star. Everything from out there is on a leash, bound to the sun, coming round again and again over centuries, but this one was different from the first measurement. Its path was too steep, too fast, too open. It wasn't going around the sun on a leash. It was passing through on a trajectory that could only mean one thing. It came from outside. It was an interstellar object, the first one we'd ever caught in the act, a visitor from another star system just cruising through ours. Let me be precise about how we knew that, because it's not a guess. It's orbital mechanics, the plain arithmetic of how things fall around the Sunday. Anything bound to the sun traces a closed loop, an ellipse, a shape that comes back on itself. But this object's path wasn't a closed loop at all. It was open, a curve that comes in once and leaves forever. and its speed was the giveaway. It was moving faster than the sun's gravity could ever have given it. Faster than escape velocity, that minimum speed you need to break free of something's pull and never fall back. If it's already going faster than escape velocity when it's far out, then it was never captured. It just fell in from the dark, whipped once around the sun, and headed back out. The maths leaves no wiggle room. This thing was born somewhere else. And here's how you can feel that in your gut without any equations. Roll a marble toward a bowl. If it's going slowly, it curves down into the bowl and settles, circling the bottom. That's a captured object, bound, coming round again and again. But if you flick that marble hard enough, it races down one side of the bowl, up the other, and flies right off the rim, never to return. Same bowl, same gravity. The only difference is speed. This object was flicked hard, too hard to have come from our bowl at all. It came over the rim from somewhere else, dipped through, and left over the far rim. One pass, no return ticket. Sit with the arithmetic of that for a moment, because it's humbling. The distances between stars are so vast that anything crossing them has been traveling for an unimaginably long time. Remember that 70,000-year number for a probe to reach the nearest star? Now flip it around. Whatever star flung this rock our way, it took a journey like that, and probably far longer, drifting through the black between the stars for millions of years, maybe hundreds of millions, before it happened to thread through our little neighborhood. In the few weeks we had the instruments pointed the right way, we very nearly missed it entirely. We caught it on its way out, already leaving. A single ship in the night, spotted only by its wake. And then it did the odd thing. As it swung away from the sun and headed back out toward the dark, it sped up. Just slightly, but it sped up more than gravity alone could explain. Now, that phrase deserves care, so let me be precise. Gravity is predictable. You know exactly how fast the sun's pull should let something go, and this object was going a touch faster than the maths allowed. That little extra push is what people mean by non-gravitational acceleration. Something other than gravity nudged it. Now, here's where our toolkit earns its keep. Because your mind, my mind, everyone's mind, wants to leap straight to the exciting answer. A push that isn't gravity. A visitor from another star, speeding up as it leaves. Surely that's an engine. Surely that's a sail. Surely that's someone. But stop. What's the plainer story? For an ordinary comet, we already know the mechanism. As a comet warms near the sun, ice buried inside turns straight to gas and jets off one side, and that jet acts like a tiny thruster. A comet is a rock that gives itself a gentle shove by breathing out. Point a garden hose off the back of a boat, and the boat inches forward. Same idea in the vacuum, with vapor instead of water. So a little unexpected acceleration is not a smoking gun at all. It's practically the resume of a comet. Occam's razor is tugging your sleeve hard. A knocked over lamp. Reach for the cat before you reach for the burglar. Except, and here's the turn, this one didn't look like a comet in the usual way. A comet that's venting gas usually shows a tail, a visible fuzz of released material streaming off it. This object didn't show the obvious signs you'd expect. No bright tail, no clear cloud of gas around it that our instruments could pin down. And that's the tension. The behavior said comet. The push was there, but the usual visible fingerprint of that push was faint or missing. And when your evidence pulls in two directions like that, the honest answer is not to pick the exciting side. The honest answer is to say out loud, we don't fully know. And that we don't know is not a failure. It is the single most scientifically literate sentence in the language. And there are plainer stories still that fit. If you keep hunting, maybe the gas it vented was of a kind our instruments weren't well tuned to catch. Some ices turn to gas without the bright glow we're used to seeing. Maybe it was made of something unusual, spat out by whatever process built it around its home star, that jets away invisibly. Maybe it was simply small and shaped oddly. So a faint push from sunlight itself, The gentle pressure that light exerts on anything it touches was enough to nudge a lightweight object off its expected track. Every one of those keeps you inside the world of plain rock and plain physics. None of them needs a crew. And that's the discipline. You exhaust the ordinary explanations thoroughly, patiently, before you let yourself so much as glance at the extraordinary one. Not because the extraordinary one is forbidden, just because it hasn't earned its turn yet. Then, years later, another one came. A second interstellar visitor cataloged and tracked another object plainly from beyond our own star's neighborhood on the same kind of open, unbound path. And each time one of these turns up, the same drama plays out in miniature. The steep foreign path, the strange nudge, the chorus of voices insisting it must be a ship, and the quieter, harder discipline of asking what a rock could do on its own before we credit it to a crew. And here's what's quietly thrilling. We're getting better at catching them. Our surveys are sharper now, sweeping the whole sky, night after night, comparing one night's picture against the last, flagging anything that moved, which means these visitors were probably passing through all along for all of history, and we simply couldn't see them. The traffic was always there. We just finally opened our eyes. But here's the implication I really want you to hold, because it's bigger than any single rock. These objects are proof of traffic, not proof of anyone driving, but proof that material crosses between star systems, that the space between the stars is not a sealed wall. Things travel it. Debris, ice, rock, the leftovers of other worlds, drifting for aeons and occasionally passing through our porch light. The gap between stars leaks. And if plain rock can make that crossing, then the door is open for the more interesting question: what else might? Because the same physics that carries a rock across that gap would carry anything: a spore, a seed, a signal, a ship, if a ship were patient enough. The rock doesn't prove any of those crossed. It only proves the road exists. And notice the shape of what just happened, because we're going to do it again. We took a genuine observation. We felt the pull toward the thrilling answer. We reached instead for the plain mechanism. And we ended up somewhere more honest and, I'd argue, more astonishing than the thrilling answer would have been. A universe where matter routinely crosses between the stars, where pieces of other worlds fall past our windows. That's the real signal in the rock. Now let's do it again with something much stranger. Here's the next claim to put on the table. We have looked deliberately, systematically, for signals from other civilizations. And the silence we found is itself one of the most important pieces of evidence we have. The quiet is data. Let me convince you why. Start with a number game, one you can play in your head. Our galaxy holds something on the order of a few 100 billion stars. That's 100,000 million and then some. Most of them, we now know, have planets. We've found thousands of these exoplanets, worlds orbiting other stars, and the count keeps climbing every year. And a fair fraction of those planets sit in what gets called the Goldilocks zone, the orbit that's not too hot and not too cold, where liquid water could sit on a surface without boiling off or freezing solid. Not too much energy, not too little, just right. Let me put a floor under that fair fraction, because it matters. Even if you're stingy about it, even if you say only 1 star in 5 has a rocky world in that comfortable zone, look what happens. A few 100 billion stars divided by 5 still leaves you tens of billions of potentially livable worlds in one galaxy. And there are hundreds of billions of galaxies. The numbers don't just get big. They get big in a way your intuition simply refuses to hold. You cannot picture tens of billions of anything. Nobody can. And that failure of imagination is exactly where the trouble starts, because those numbers are screaming one thing while the sky is saying another. Let me try to make that number less abstract, just for a moment. Suppose you decided to count those livable worlds, one every second, out loud, no sleep, no breaks. 1, 2, 3. To reach 10 billion, you'd be counting for over 300 years. You would die, and your grandchildren would die, and their grandchildren long before you finish counting just the friendly worlds in our own galaxy alone. Now multiply that by hundreds of billions of galaxies. There is no version of a human mind that can hold this. And the mediocrity assumption is standing right beside all those worlds, whispering that our story, the one where a rock grew life and then grew curiosity, probably isn't unique. So run that assumption all the way. If we're ordinary and water worlds are common and chemistry is the same everywhere, and it is the same elements light up in distant starlight as light up in a candle flame, then life should not be a one-off miracle. It should be a tendency. And if life is a tendency, then given the sheer number of chances, billions of worlds, billions of years, some of it should have grown clever, some of it should have built things, some of it should be shouting into the dark the way we shout. And this is where a genuinely uncomfortable question lands, one that a physicist is supposed to have blurted out over lunch. If the galaxy should be crowded, then where is everybody? That's the Fermi paradox in one line. The numbers scream that we should have company. The sky is silent. Those two things do not fit. And the mismatch between them is one of the sharpest, most honest puzzles in all of science. Sit with it. Everything says the room should be full, and nobody has knocked. Now, some people try to organize the guessing with a tool called the Drake equation. Don't let the word equation scare you. It's not really a calculator. It's a way of breaking one impossible question into a chain of smaller ones. How many stars are there? What fraction have planets? What fraction of those could bear life? What fraction of those actually do? What fraction of that life gets clever? What fraction of the clever ones build signals we could catch? And how long do they keep signaling before they go quiet? Multiply the chain together, and out pops a guess at how many civilizations we might hear right now. Here's the beautiful, maddening thing about that chain. We know the first number pretty well, lots of stars. We're getting a decent handle on the second and third thanks to all those exoplanets. But the numbers near the end, the ones about how often life gets clever and how long it lasts, we have exactly one example to work from, us. And you cannot build a reliable statistic out of a single data point. One is not a sample, one is an anecdote. So the honest truth is that the Drake equation doesn't give you an answer. It gives you an inventory of your own ignorance, neatly itemized, and that is genuinely useful because now you know exactly which questions are the expensive ones. Look at how lopsided our knowledge is laid out that way. The front of the chain, the star counts and planet counts, we're nailing that down year by year with real instruments and real measurements. But that last term, how long a civilization keeps signaling before it falls quiet, could be anything from a few decades to a few million years. And the whole answer swings wildly depending on which it is. If civilizations typically last a few million years, the galaxy might hum with them. If they typically last a few centuries, then even in a fertile galaxy, at any given moment, almost all of them are already gone. And the few that remain are scattered so thin you'd never find them. Same galaxy, same biology, wildly different sky. And we cannot tell you which one we live in because we've only watched ourselves and only for a heartbeat. And here's the part that should give you pause about ourselves. We have only been sending signals worth catching for about a century. 100 years out of a planet that's billions of years old. If some neighbor had been listening in our direction for all of history, they'd have heard nothing, 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 and then in the last blink, a whisper. And we don't know how long our own whisper will last. That last term in the chain isn't just a fact about aliens. It's a question about us hanging in the air unanswered. So we listen, we build antennas, and we sweep the sky for any narrow, deliberate pattern signal, a technosignature, some fingerprint of technology that nature wouldn't make on its own. And that phrase matters, that nature wouldn't make on its own. Because nature is loud, stars crackle. Spinning dead stars pulse with almost mechanical regularity, so regularly that when the first one was found, people briefly wondered if it was a beacon. It wasn't. It was physics. So we're not just hunting for a signal, we're hunting for one that's too clean, too narrow, too deliberate to be an accident of physics, and every so often a blip, a candidate, something that made a room full of careful people sit up straight. And the process that follows is the whole discipline in miniature. Can we see it again? Can anyone else see it? Is there a dull earthly explanation? A microwave oven in the break room? A passing satellite? A phone left on near the receiver? A glitch in the machine itself? And over, the exciting blip resolves into something ordinary. A door left open, a stray reflection, our own noise bouncing back at us. Let me give you the flavor of how careful this has to be. There was a famous burst decades ago, so strong and so strange that the person who spotted it scrawled a single word beside it out of pure astonishment, and it never came back. It was never seen again from that patch of sky or any other. And that right there is the agony and the honesty of the whole enterprise. Because a signal you cannot repeat, a signal nobody else catches, is not evidence you can build on. It might have been the most important thing we ever detected. Or it might have been a fluke, a piece of local noise, a reflection off something passing overhead. And the discipline demands that you sit in that uncertainty forever if you must, rather than declare victory on a single glimpse you can't reproduce. That's not weakness. That's the strongest thing a searching mind can do. And notice why the repeat matters so much. It's the falsifiability tool again, wearing work clothes. A signal that comes back that others can point their own instruments at and confirm is a claim that sticks its neck out and survives. A signal seen once by one machine that never returns is the invisible dragon. There's no way for reality to argue with it one way or the other. So we don't get to build on it, not because we're timid, because that's the rule we agreed to at the start, the rule that keeps the con men out. But notice, and this is the turn, the silence isn't nothing. The silence rules things out. It tells us that whatever is out there, it is not blasting obvious signals in our direction at the frequencies we've checked in the time we've been listening. And each of those is a real hard boundary. We can now say, with a straight face, that a galaxy stuffed with loud, nearby, eager broadcasters is not the galaxy we live in. That's been falsified, killed by the quiet. The dragon in the garage was supposed to breathe fire. We checked. No fire. And here's the implication that gives me chills. In the good way, there are only a handful of explanations for the silence, and every single one of them is enormous. Maybe life is far rarer than mediocrity suggests, and we are close to alone, the first or nearly the first to sit up and look around. Maybe clever life is common but short-lived, burning out before it can be heard, which is a sobering thought about ourselves and about how young and fragile our own signaling really is. Maybe they're out there but not shouting, listening quietly the way we mostly do, both sides sitting in the dark with the microphone off, afraid or wise or simply patient. Or maybe, and this is the humbling one, the distances and the timing are simply so vast that two civilizations passing in the same galaxy almost never overlap, like two ships crossing the same ocean 1,000 years apart. Every one of those answers reshapes your sense of your own place in things. The quiet is not empty. The quiet is full of meaning. We just haven't decoded which meaning yet. Same shape as the rock, you see a real observation, the silence. The pull toward a thrilling story, the discipline of the plain question, and an ending more profound than the fantasy. Now let's go somewhere that will stretch you more than either. Here's the third claim, and it's the biggest one yet. There is a hard wall on what any of us can ever see, a limit built into the universe itself. And past that wall lies information we are physically forbidden from ever collecting. Not because our tools are weak, because of what the universe is. Let me walk you to the wall slowly. We said light carries the past, and the further out you look, the deeper into history you see. So push that to its extreme. Keep looking further and further and further out. You're seeing younger and younger versions of the cosmos, and here our newest, sharpest eyes have done something wonderful. Point the most powerful space telescope we've ever built at the deepest dark, and it finds galaxies so far away that their light has been traveling almost the whole age of the universe to reach us. We're seeing them as infants, freshly formed, glowing in the young cosmos. That light is a message from the beginning, and it took nearly everything there is of time to arrive. But keep pushing past even those infant galaxies. And eventually you reach a moment when the universe was so young, so hot, so dense that it was a glowing fog, not transparent, opaque, like the inside of a cloud lit from within. Light couldn't travel freely through it. It just scattered endlessly, going nowhere. Every particle of light got knocked sideways the instant it tried to move, like trying to see across a crowded, brightly lit room full of fog, no line of sight, just glow. And then the universe cooled and cleared and became see-through, and the light that was trapped in that fog was suddenly set free to fly across all of time and land, eventually on us. We can detect that light right now. It's real. It's the oldest light there is, the afterglow of that clearing moment, stretched and cooled by the expansion of the universe into a faint hum of microwaves coming from every direction at once. That's the cosmic microwave background, the baby picture of everything, the furthest back we can see with light. And here's the astonishing part, the part that should make the hair on your arms stand up. That glow is falling on you right now, this second, from every direction. It passes through you. It always has. It's the single oldest thing you will ever come into contact with, and it's everywhere, all the time, invisible, only because our eyes weren't built for it. And here's the wall. We cannot see past it. Not with any telescope, not with any future technology, not ever using light. Because before that moment, the universe was opaque. There is no earlier picture to take. Because before that, no light could travel to carry the picture. The cosmic microwave background isn't just the oldest thing we see. It's a curtain, a hard edge on the visible past. It's the closest thing the universe has to a "you may not look further" sign, and it's not a suggestion, it's built into the physics. Now watch the light carries time idea do something even stranger. Because the universe is expanding, distant things are being carried away from us, and the further away they are, the faster they recede, until eventually they're receding faster than their light can ever close the gap to us. The light gets stretched, its color dragged toward the red end of the spectrum, redshift we call it, and past a certain distance the stretch becomes total. Those galaxies are still out there, but their light will never, ever reach us. They have crossed a kind of horizon. Let me make sure that redshift idea is solid, because it's the engine of the whole thing. When something that's giving off light moves away from you, the waves of that light get stretched out, and stretched out light looks redder. You've heard the cousin of this with sound, an ambulance siren dropping in pitch as it races past you. The sound waves stretch, the pitch falls. Light does the same. And in an expanding universe, everything distant is racing away, so its light arrives stretched, reddened. And the more distant it is, the more stretched. Push that far enough, and the stretching goes to infinity. The light is stretched into nothing before it can ever arrive. That's the edge, not a wall you could fly to, a wall written into the growth of space itself. That word matters, and you may know it from a very different place. An event horizon is the boundary around a black hole, the line past which nothing, not even light, can climb back out, because you need to go faster than light to escape, and nothing can. It's the ultimate version of escape velocity, that minimum speed you need to break free of something's gravity. Throw a ball up, it comes down. Throw it fast enough, it never comes back. For a black hole, the required speed passes the speed of light, and light itself gets trapped. But here's the beautiful, eerie symmetry. The expanding universe gives us a horizon too, a cosmic one. And beyond it lie whole galaxies we can never reach and never hear from, cut off not by gravity, but by the stretching of space-time itself. And there's a deep honesty forced on us here that I love. There are things we suspect fill the universe that we cannot see at all, only feel by their pull. Galaxies spin faster than the visible matter in them should allow, as if held together by something heavy and invisible, and we call that dark matter, a name that is really just an honest label for a gap in our knowledge. We can even watch its gravity bend the light of things behind it, a warping we call gravitational lensing, where a massive clump in the foreground acts like a lens and smears the light of a distant galaxy into arcs and rings. Think about how strange that is. We can map something we cannot see by watching the way it distorts the light of things behind it, the way you can spot a clear pane of glass by the way it bends the view. So even inside our reachable bubble, the universe keeps reminding us how much of it is present but unseen, not walled off by a horizon, just quietly refusing to glow. So now hold both walls in your mind at once. There's a wall behind us in time, the cosmic microwave background, before which we cannot see. And there's a wall around us in space, the cosmic horizon, beyond which we cannot reach. We are living inside a bubble of the observable. And outside that bubble is more universe, possibly vastly more, that is not hidden from us by distance. We might one day cross, but forbidden to us by the rules of the game. And here's the implication I want to leave burning. This means the honest answer to what's out there has a hard, permanent boundary baked into it. And that changes the whole flavor of the search for signals. Because when we ask whether anyone's out there answering, we have to add a brutal footnote. We can only ever be asking about the part we can reach. There could be a galaxy roaring with civilizations, signaling with everything they've got right now, forever out of contact. On the far side of a horizon, their light will never cross. Not silent, just unreachable. And we would never know the difference between a universe that's empty and a universe that's full but walled off from us. Same shape once more, a real feature of the cosmos. These two walls, the temptation to feel defeated by them, and instead a more profound understanding that some of our loneliness might not be loneliness at all. It might just be the horizon. Now let me show you why all three of these things have been pointing at the same place the entire time. Look back at the three strange things we've walked through and watch them fold together into one shape. The rock told us the space between stars is not sealed. Matter crosses it, slowly, over aeons, but it crosses. The silence told us the sky is not full of loud, close, eager broadcasters, and gave us a short list of enormous reasons why. And the two walls told us that our view of everything is bounded in time and in space by limits woven into the universe itself. Three different puzzles, three different corners of the sky, and they all say the same quiet thing. Distance and time are the same currency. That single idea, the one we built right at the start, is the thread running through all three. Watch it. The rock had been traveling for millions of years to cross a gap of a few light years. Distance paid for in time. Remember, even our fastest machine would take 70,000 years to reach the nearest star. So any real crossing between stars is a crossing through deep time. Whoever or whatever makes it. The silence might just be the sound of civilizations separated not only by space, but by history. One flourishing while the other is still amoebas, missing each other by epochs, the way you'd miss a friend by showing up to the meeting place 1,000 years early. Distance in time. And the walls, the deepest version of all, where the oldest light is simply the past that hasn't finished arriving, and the unreachable galaxies are places so far in distance that they're effectively lost in time as well. Every one of these puzzles is the same puzzle wearing a different coat. To be far away is to be far back. To be far back is to be, for all practical purposes, unreachable. And here's the thing, almost nobody sees when they ask whether we're alone. They picture a room, a big dark room, and the question is just whether anyone else is standing in it. But that's the wrong picture entirely. It isn't a room. It's an ocean of both space and time together. And we're not asking whether anyone else exists in it. We're asking whether anyone else exists close enough and at the same moment of cosmic history and inside our horizon for a signal to make the crossing while both of us are still here to send and receive it. That's a staggeringly narrower question. Think of how many ways two civilizations can miss each other. Too far in space and the signal never arrives. Too far in time and one is dust before the other is born. Beyond the horizon, and contact was never even possible. You have to thread all of those needles at once. And when you see how many needles there are, the silence stops being spooky. It starts being almost expected, And that reframing does something I find genuinely beautiful. It takes the silence, which felt cold and frightening, and shows you it might be the most natural thing in the world. Not a verdict that we're alone, just the honest arithmetic of an ocean this size. Two ships can share the same sea and never see each other's lanterns, not because the sea is empty, but because it is so unspeakably large, and because they sailed in different centuries. So, let's return to where we started. We sent a signal into deep space, and it felt like something answered. What was the answer, really? Every time we've looked closely, the thrilling reply has resolved into something else. The rock's mysterious push, most likely a rock breathing out gas. The blip in the antenna, most likely our own noise handed back to us. The apparent answer from the dark, most likely the echo of our own hope, dressed up in the shape we wanted to see. And I want to be so clear that this is not a disappointment. This is the most beautiful discipline the human mind has ever built. The willingness to look straight at the answer you were desperate for and ask it to prove itself and let it go when it can't. Because the truest signal that came back from deep space wasn't a message from anyone. It was a message about the shape of the search itself. It taught us how big the ocean really is. It taught us that distance and time are one thing. It taught us where the walls are. And it taught us that the silence, far from being empty, is one of the most information-rich things we've ever measured. The dark answered. It just didn't answer with a voice. It answered with a map of exactly how hard the question is. So let's bring it home. Let's walk back through the whole thing together, because I think it lands differently now than it did at the start. We started with a stone thrown into a dark ocean and the feeling that something threw one back. And before we let ourselves believe or disbelieve, we built a toolkit. We agreed that light carries the past, so that to look far is to look back, and distance and time are the same currency. We proved that to ourselves with a simple sum. 150 million kilometers divided by the speed of light, 8 minutes to the Sunday. We agreed that an idea is only worth trusting if it's falsifiable, if some observation could kill it. And we saw the difference between an invisible dragon and a planet that dims a star on schedule. We agreed to reach for the plainer explanation first, the cat before the burglar, and make the universe prove it needs the fancy one. And we agreed humbly to assume we're not special, and noticed how every time in history we bet against that, we lost. Then we met the rock, the interstellar visitor with the little extra push, the non-gravitational acceleration that set everyone's imagination on fire. We knew it came from outside because its path was open and its speed was past escape velocity, pure orbital mechanics, no room to argue. The marble flicked too hard to stay in the bowl. And instead of crowning it a starship, we asked what a plane comet could do on its own, breathing out gas like a hose off the back of a boat, and we found the honest answer sitting in the uncomfortable middle. We don't fully know, while the deeper lesson stood out clearly. Matter crosses between the stars. The gaps leak. The door is open. Then we met the silence, the Fermi paradox, the crowded numbers that should mean company. Tens of billions of livable worlds in our galaxy alone, more than you could count out loud in 300 years, set against a sky that won't speak. We use the Drake equation not as a calculator, but as an honest inventory of what we don't know. And we saw how the whole answer swings on that one last term. How long a civilization lasts before it falls quiet, a question that turns out to be about us as much as anyone. We let the quiet do its work, ruling out the galaxy full of loud, close neighbors, and leaving us with a handful of possibilities, every one of them enormous. Rare life, short life, quiet life, or life scattered too far across time and space to ever overlap with ours. And then we met the walls. The cosmic microwave background, that curtain of the oldest light, the fog that cleared and set free, a glow that falls on you this very second, behind which we cannot ever see. And the cosmic horizon, the edge beyond which galaxies recede faster than their light can reach us, lost to redshift and the stretching of space-time, an event horizon written across the whole sky, the cousin of the escape velocity that traps light inside a black hole. And we learned the hardest lesson of all. that we can only ever ask our question about the part of the universe we can reach, and that a cosmos both empty and a cosmos full but walled off would look to us exactly the same. And then we watched all three fold into one. Distance is time. The room is an ocean. The real question was never just, is anyone there, but is anyone there close enough, now enough, inside the walls to answer while we're both still listening? So many needles to thread at once, and under that light, the silence turned from something frightening into something almost tender. Not proof we're alone, just proof of how vast the crossing is. That's the journey. A stone in the dark and an answer that turned out to be a map. Now, let me be honest with you about what's still wide open, because that honesty is the whole point of this way of thinking. We do not know how often life begins. We have one example, ourselves, and one is not a number you can build a statistic on. We do not know whether life reliably becomes clever, or whether that's a fluke that happened once in the corner of one galaxy. We do not know how long a technological civilization lasts, which is a question about our future as much as anyone else's. And it's the very term that swings the whole Drake chain from a crowded galaxy to an empty one. We do not know for certain what pushed that interstellar rock, only what most likely did. We do not know what most of the universe is even made of, only that its gravity is there, tugging, bending light, refusing to glow. We do not know what lies beyond the walls, and by the rules of the universe, as we currently understand them, we may never know. And honest people have to be able to say that out loud without flinching. And we do not know whether the next strange signal, the one that hasn't arrived yet, will resolve into noise like all the others, or whether one day it won't. That last one keeps the whole enterprise alive. Because every one of these open questions is the good kind of open. The kind with a boundary you can point to. We can say exactly how far our ignorance extends and exactly which observation would shrink it. Find a second independent example of life beginning. Even a microbe on a nearby world. A smudge of a biosignature in the air of some distant planet. Some chemical fingerprint that only living things leave behind, and suddenly that first Drake number stops being a guess. Catch a signal that repeats, that others can confirm, and everything changes overnight. That's not the frustrating darkness of a question that can't be asked. That's the thrilling darkness of a question that just hasn't been answered yet. And there is a world of difference between the two. And that difference is the thing I most wanted to hand you today. The universe is knowable. It is simply not yet known. And that gap, that enormous echoing gap between what could be understood and what has actually been figured out, is not something to be nervous about. It's the invitation. It's the reason any of this is worth doing at all. If it were all already known, there'd be nothing left to look up at. The unfinished part is the best part. So the next time you stand under a clear night sky and feel that old pull, that mix of wonder and smallness, I want you to remember what you're actually looking at. Not a ceiling, a stack of photographs, each from a different age, pinned to the dark. Light from stars that may already be gone. A curtain of the oldest glow just beyond the reach of your eye, and passing through you even now. And somewhere out there, past walls of distance and time, maybe another creature under another sky, looking back this way. Both of you throwing stones into the same dark ocean, both of you waiting to hear where they land, we threw ours. Something seemed to answer, and the answer, it turned out, was the size of the sky itself. Thank you for spending this time with me. Genuinely, there are 1,000 things you could have done with this stretch of your day, and you chose to sit with a hard, beautiful question and follow the reasoning all the way through, step by step, without needing anyone to tell you what to believe. That's a rare and wonderful thing, and I don't take it lightly. If you'd like to keep wandering through corners of this knowable, not yet known universe together, I'd love it if you'd subscribe and come along for the next one. There's so much more sky to look at, and I can't wait to look at it with you. Until then, keep your eyes up and keep asking the questions that have a boundary you can point to. Those are the good ones. Take care.